welcome to us is Luis Gerardo Zarete. He is from Mexico. He is here also as a partner of PSF Space. He works on small satellites. He's actually a project manager of small sats and also sounding rockets. Luis?
Can you hear me? Okay. Well, hello. I think that I'm going to speak in English. I would like to speak in Spanish, but I don't know if anyone understands Spanish. And I can also speak in French, but I think that that wouldn't work very well because I've been a lot since I don't speak French. So, well, let's speak English. Yes, my name is Luis Arate. I come from Mexico. So, for you, I think this is going to be very interesting because Mexico, like Morocco, is not like a country that has a history of a lot of space in the space industry. We are developing a space industry just like you, and so the experience that I'm going to share with you maybe are going to be for a lot of interest for you because you're going to feel, I think, that involved. First, for this, well, this is not going to be as technical as previous talk, but it's going to be a little bit technical. So I hope that you won't get sleepy. First, well, the company is called Edison Effect. So it's a very interesting company because we do a lot of different things. First, I'm going to start telling you a little bit of the history of the company, and then to put you in the context, and then I'm going to explain you the main reason of the talk. That's going to be about two revolutions: the revolution of small satellites, and the revolution of Internet of Things. I don't know if you are familiar with the concept of IoT. It's another revolution, and how these two revolutions are working together. Okay, so the company is called, well, was called Datiotech. It's a company that was founded in 2008 in San Luis Potosí. San Luis Potosí is a state in the center of Mexico. The first goal of the company was to develop electronics for the consumer market. What do I mean by that? Well, our first product was a smart lighting control, like a switch, like these ones, but that allows to program different things with light, so it was a little bit smart. The company started with just 3 people and then began to grow. But what was interesting about this is that we built a very, very good lighting control and we didn't sell anyone. There are not a single control of these ones. So what did we do? Okay, we did another version of the same control and with the same result. It was a very good product, but with no sales. So the people at the company start to wonder why we don't have any sales. And this was in 2008, and they discovered that even if the product was very good, the timing was not perfect. So people were not ready in Mexico to this kind of technology. A lot of years passed, and we start developing different things with electronics that I will tell you later in the presentation. But we start working also in different kinds of projects, very ambitious projects like space. But first, I'm going to talk you about this other company that's part of the same group. That's called Biocor Labs. This company, we do biomedical research. So, for example, we have 2 big projects. One is an obstetric balloon. I don't know if you are familiar with the term. In a few words, when women are going to, when a baby is going to be born, sometimes the mother starts bleeding out. So it's very difficult to stop the bleeding, and it's a cause of death in many countries. This balloon, it's an electronic balloon, an automatic balloon that will help, especially not in the cities but in the countryside, to help the women that are suffering from this phenomenon. And another one is an incubator for treating brain hypoxia. This means that when the baby is born, sometimes it doesn't get enough oxygen, so it's necessary to cool down the baby, just a little bit, not a lot. It's not like freezing the baby. But with this therapy, we make sure that the brain doesn't suffer any damage. So these are two of the projects of this company. And now the company that you're interested on is Data Aerospace. Data Aerospace was born in 2013. It's a member of KSF Space. The projects of this company are partially funded by the Mexican government. We depend a lot of funding from the Science Council and other institutions from the government, because as I told you, we start like a very small company. So space, maybe in the United States, maybe in Europe, small companies can get into space, but in Mexico it's a little bit difficult because we don't have a developed industry. So for a company to get into space, it was like something very crazy. Actually, we are the first Mexican company that actually develops space technology. There are another companies, but they are manufacturing companies or companies that just are in charge of putting companies together to get funding. This company started with this project. It was a universal plug-and-play bus, or a small CubeSat. The idea behind this project was to develop a small satellite, but that could be universal. Just like the USB plug that you use for your computers, that you can get a mouse and plug it into the computer and it will work. This satellite, the idea behind it was that if you have an experiment, you just develop the experiment following our guidelines, and we can make sure that it will work when we put it together. This is a big challenge for satellites. Usually when you are developing a satellite, if you have an experiment, putting together everything takes a little bit of work, sometimes, and we wanted to reduce this time. Doing this project, it's how we start to collaborate with different people, including KSF, the Mexican Space Agency, but also the Air Force and the Navy. There were a lot of people that were interested in this project, so we started to grow. And that's when we decided to go with the next project. It was a little bit more ambitious. It was a small rocket, because we found that, okay, I have this small satellite, but if I want to launch it, I need to ask for NASA or ESA or come to India, to all of these countries that already launched small satellites, but it will take 2-3 years and several $1,000s. So for countries like Mexico, maybe CubeSats are cheap, but they are not as cheap as we needed. I mean, so we start to develop this rocket. It's not an orbital rocket. It means that it doesn't go around the Earth. It just goes up to the space and then it falls down. But this kind of rocket has a huge market also, because it turns out that in Europe they don't have they have very few rockets of this type, and there are a lot of researchers that want this kind of opportunities for launching experiments. So this rocket has a payload capacity of 10 kilograms. It's a very small rocket and can reach an altitude of at least 100 kilometers. That's the limit of the space. Space is defined to be above 100 kilometers of altitude. And we want to have a cost per kilogram of $5,000. That's it's a little bit expensive for the suborbital rocket, but I think it's a good price for the market, especially for the market from different countries like Mexico, Brazil, or Israel. Also for this project, we're working together with these 3 countries. I want to show you the video, a small video that we did to present not this version of the rocket, a previous version of the rocket, and then I will continue. Okay, well, that was just a previous presentation of the rocket. This is a new version. This is still an ongoing project, but we are right now it's on hold because we need money. Actually, the policy in Mexico for space projects have changed a little. This is going to be a new government that has a little bit a different idea about how to fund science projects. They want to focus on agriculture and this kind of projects instead of space and more technological projects. So, well, it's a little bit uncertain how it's going to work for us. But at the end, as we have different kind of projects, we will survive, that's for sure. So this year the company merged all the companies that I showed you and became Edison Effect. Why this name? Well, Edison Effect is the name of the phenomenon that allows transistors to work. So as we are an electronics company, we decided to put this name for the company. And okay, so now talking about Internet of Things. This is a definition. There are a lot of definitions of Internet of Things. This one means that this one says that everyday physical objects that are connected to Internet. So, for example, we can say about wearables, watches, but also the switches here. Everything is going to be connected to Internet. So that's a little bit scary, but that's also true. Is how it's going to be. So this revolution is growing a lot. A few facts. These facts are from the IEEE. More than 50 billion of devices are going to be connected by 2020. Different architectures, a lot of data is going to be produced, also for different applications, consumers, commercial, industrial, a lot. And different business approaches. So this is going to be something, it's not going to be. It's being something huge. It's going to be a complete revolution of how things work for us. So there are different technologies that are used or that enables this kind of, these devices. The ones like Bluetooth, for example, not a new one, but with some advantages, for example, in consumption, power consumption, but the problem that the range is very little. So you have a range of 10 meters, or if you're lucky, up to 100 meters, but no more. Wi-Fi, a lot of power consumption, that's a drawback. Different other technologies like Zigbee, 4G, 5G that's coming. And these two technologies, let's see if this works, yeah. LoRa and Sigfox. These kind of technologies are specific designed for IoT devices. They are very low power consumption. They work like the cell phone. For example, you can put a device in your house and it's going to send data directly to internet, so you don't need another device. And you can check in your cell phone, for example, the data, even if you are in the other part of the world. And especially this technology, Sigfox. I'm going to talk a little bit about Sigfox. Sigfox is a French company, and the technology is a narrowband technology that requires only an expensive endpoint radio and base station. That means that we have very cheap devices that can be installed on everyday devices to enable this technology. It's low bandwidth, meaning that we can send very few bytes of data, up to 12 bytes per message. It's very cheap. For example, for you, if you want a device with this kind of technology, it's going to cost you around $1.60 per year. That's the plan. And depending on the subscription, you can get 250, 100, or up to 140 messages per day. So you are limited in the number of messages that you can send to the cloud. This is right now the coverage of Sigfox. The countries in purple are the ones that already have coverage, and the areas in blue are the cities that are receiving coverage. As you can see, Morocco doesn't have coverage yet, but I'm sure that in the following months or years it's going to have this technology because it's growing very fast. It has some pros and some cons. For example, in the advantages of this technology is that is very low power. The devices can be powered by a single small battery. There are few interferences. There's supposed to be an anti-jamming technology. It's very cheap. It's long range. It can be used in conjunction with other technologies like Wi-Fi or Bluetooth or 4G, etc. The problems of this technology is that you have a limited number of messages. I said up to 140. Very few bytes of data. 12 bytes. Maybe you don't know what is 12 bytes or what does it mean 12 bytes. But for example, if you want to send a picture is around 2 megabytes to 4 megabytes. So we are talking like thousands of times more than the capabilities of this kind of technology. So this is a problem. You cannot send pictures and video, of course not. It has limited bidirectional connectivity, meaning that it's very easy for the device to get data, to send data to the cloud, but it's not that easy to get data from the cloud. You can send, for example, your device is going to be installed in your house. You can send data to the cloud, but if you want to control something in your house, that's not that easy. It's very limited in that case. It has right now limited coverage outside Europe, but it's growing, and very low data rate. That means the speed of data that can be sent. Very quickly, I'm going to present this case. It's a use case, so you can understand how this technology works. And this is a small sensor that's developed by us. I don't know how it works in Morocco, but in Mexico, if you want to have gas in your house, most people have tanks that are installed in the roof of the houses. So if you want to, for example, at the beginning of the month, the supplier comes to your house and fills the tank, and then it goes and it doesn't come back until you call them. This means that sometimes you are going to, for example, take a shower, and then you discover that you don't have any gas in your tank, so you have to call the supplier and he will come to your house. And because the tank is on the roof, usually you don't know how much gas you have left in the tank. So this device you install in your tank, and you will receive the reading, the level of gas in your cell phone. The first version of this device used Bluetooth. The problem was that it has limited range. So for example, if your tank is right above you, it will be fine, but if you are in a 3-story building, 4-story building, that won't work. The second version uses Sigfox, so the device sends the data directly to internet. And I can be here in Morocco and I still can check how much gas I have left in my house. This is good, but what happens if we want to try? If we want to track, I don't know, an asset, a truck, our vehicle, our car? Sigfox wouldn't work right now because it's like we have antennas in the cities, but if you are on the road, if you're in, you won't have coverage. So that's where satellites come into play. Well, I think that everybody knows what's a CubeSat. If not, just a very quickly explanation. CubeSat is a very small satellite. It's 10 by 10 by 10 centimeters, and it weighs 1 kilogram. But, well, it can be used alone or it can be stacked in different modules of up to 16 satellites together. These are very cheap satellites, very cheap. They work for different kinds of missions, technology demonstrations, science, educational projects, commercial, military, a lot of applications for this kind of satellites. And they have a lot of advantages, like it's very, usually a satellite you take 10 years to develop, more or less 10, 15 years, but this kind of satellites can be built within 2 years. They are very fast to build. They are less expensive, far less expensive than large satellites. The technology is very simple, it's a standard, and you can use components that are commercially available. The design is very simple, and well, they're supposed to burn in the atmosphere when they are re-entering, but the space debris thing I think is not very right now solved. Sometimes I think they can be worse than anything. But well, the disadvantages, the scope, well, they are very small, so they are limited in the capacity of the instruments that they can carry, and the mission duration is like 3 to 12 months, or at most I think 2 years, no more than that, right now. But we don't have to rely on CubeSats for implementing IoT technology. This is where the CanSat comes into play also. A CanSat is smaller than a CubeSat. It's not fit for going to space, meaning that most of the CanSat doesn't go to space, but they are very good for education, for example. It's very cheap to build one of these. They will use most of the time an Arduino, and they can do a lot of things. Why I'm talking about a CanSat? Well, you will see. But now, how do you merge these two worlds? We have Sigfox is planning to launch a satellite, I think next year, to test giving coverage all over the world. It doesn't mean just a single satellite will make that you can get coverage twice a day only. So, for example, at noon and at midnight. So you have to prepare your device to send the data when the satellite hits in above you. However, this is going to be only for testing how well this works. If this works well, they are planning to launch a constellation by the end of 2020 or 2021. So CubeSats are going to be the solution for this kind of technology like Sigfox or LoRa to grow to. You can get coverage anywhere in the world. Even if you are in the middle of the ocean, you can get coverage. So this will enable a lot of more devices to be developed and an increase in the quantity of devices using this technology. This is a video that I wanted to show you. This is an experiment that we did together with KSF and the ENSIAS people. We decided to put the small device for the gas that I showed you together with a CubeSat that's going to gather data and see what happens. I will show you the video and then I will explain the results. Okay, so what did we do here? We took the small device, the level gas, and the device that's used for measuring the gas in your home, and we used it only as a transmitter for this technology, using Sigfox technology. So we got the data from the satellite, the altitude, well, the temperature, the pressure, the GPS position, and we send it to the device, and the device transmitted to the Sigfox network. Why this was interesting? For two reasons. First, one of the problems with launching a balloon like this one is that you cannot get the data unless you recover the device. This is one of the big problems. And even if you have a GPS device, for example, if the balloon falls in the ocean, or if the balloon falls in the mountain, or maybe in the road and a truck comes and crushes the device, or maybe in a town and someone sees the payload and says, "Oh, it's interesting," and takes it. There are different possibilities that this could not happen. So we need a way to transfer data to Earth. And there are different technologies, but most of them use a lot of power. For example, the battery is a problem. So as Sigfox is very low consumption, we can use Sigfox with just a small battery, and we can get the data. For this kind of data, Sigfox is perfect. You don't need a lot of bytes. And we got a surprise because this device, the gas sensor, for example, we have measured that when you install it on top of your roof in our city, in San Luis, for example, in the city there are 13 antennas of Sigfox installed around the city, and when with the device we can receive the signal in 5 to 6 antennas. 5 to 6 antennas around the city receive the signal from the device. But when we sent the device in the balloon, we were able to receive the signal in 160 antennas. That means that we cover half of the Mexican territory. So using only a small device, transmitting with to a single battery and a very small antenna. So this has a lot of possibilities. We don't have to do expensive CubeSat. We can use small satellites like this one. CubeSat like this one costs around $200, $300, more or less. So it's very inexpensive, and even it's good for education. For example, all levels of education: middle school, graduate school, high school, master. Everyone can take advantage of this kind of technology. So this is what I wanted to present: this experiment and the results. Well, I think that's. Yes, these are just the results. This is the Mexico, and those are the antennas that receive our signal. So you can see this is from here to here. It's like 1,000 kilometers. So it's bigger than I think Morocco territory. I don't know how long is Morocco. Well, then Morocco will be like from here to here, more or less. So you can cover the whole territory with one of these devices. So basically this is what I wanted to present. If you have any questions.
Thank you, Luis.